Hi, the topic is breadth first search and depth first search. In this video, I'll cover these two traversal methods by taking various examples. Breadth first search and depth first search are graph traversal methods. So we'll understand quickly the difference between them through this a small example. Then afterward, I'll take another example and I will explain you in detail. Now, for quick understanding,
next step from 5 I can move to the next 6 nodes, which is 6, 7, 8, 9, 10 and so on. So, and how many least number of steps I can actually reach this last node, which is 36. It is a problem which is what it is saying. Now, if we clearly look at the input itself is saying that okay, how the matrix will look like. -1 is nothing but okay, no snakes or no ladders. The value indicates okay, from this cell right here, this cell, as the cell is 2, we know because it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. So we know from this cell 2 I can reach the cell 15. It is the cell 17. I know from this cell I can reach cell 13. From here I know okay, from this cell which is cell 14 I can reach cell 35. It is how the input will look like. The matrix will indicate me okay, if I have some value other than -1, for sure a ladder or a snake would have been there, and the ladder would have whatsoever ladder or snake would have brought me to that location, which means to 15. If I'm standing at 2. Cool, very cool. Now you got the problem. Now let's recap. What the problem? You start from 1, you have 6 options to go to the next cell, and you have to ultimately reach in the least number of moves to the cell 36, and you have to reach this cell which is n square. Understand one thing, from 1 you have to reach n square in what? In least number of steps or the shortest distance. Whensoever something like this comes, okay, I am starting from a cell, I have 6 more options to go, and after that more 6 options, after that more 6 options, and then I want to reach from 1 to the node n square in the least number of steps, and it's kind of a graph which is being made. Something like a shortest distance from 1 to n square I need to find out, kind of, right? Why not use a graph BFS traversal? Because BFS, as I'm starting from 1 and I have these nodes, which is nodes are 6, and again nodes are 6, again at every level for every node, nodes are going to be 6, 6, 6. Which means that I would love to travel level wise to actually reach to my final node. Understood? But wait, let us see. We one thing we know, if we roll a dice we have 6 options. So from 1 cell I can reach to next 6 cells. From 1 I can reach to 2, 3, 4, 5, 6 and 7. 1, a gap of 1, 2, 3, 4, 5 and 6. Cool. But we actually also know that okay, my cell 2 has a ladder to cell 15. So for sure, I'll just not stay at 2. It will actually become a 15. It is when 1 dice, which means the dice is rolled once. It is how my state will look like. When the second time my same dice is being rolled, then I'll just move from what? From 2? No, from 15, because actually I have reached 15 because of 2. From 15, I have again 6 options to go, which is 16, 17, 18, 19, 20, 21. 16, 17, 18, 19, 20, 21. But still, I one thing no, as it was from node 17, it was actually a node 13. So I will just mark it and I'll just get a 13. Again, if I just go on making, my graph will look something like from 1 I just moved to all these nodes, from 15, which actually was replaced by 2, was moving from 16, 17, 18, 19, 20, then from every node I'm just trying the every possible nodes, and ultimately if I have the last node which is 36, I want to reach from here in the least possible way to here. Let's say if we had some node, some arrow, something like this also, was it required that we actually move from here, we actually move from, let's say, here, then here, and then again here? No, right? it is always good to actually travel level wise, that okay, because I know my answer would be at this level, so for sure I want to go at these steps to actually reach my answer. So I just want to find the shortest possible distance from my main source node to actually my main destination node. Understanding? Shortest possible distance, least number of steps from what? From 1 to n square. Here comes the level wise, the breadth wise traversal, which is BFS. Thus I will just simply do a BFS traversal, which will actually help me traverse the level wise. Okay, initially I start from here, the distance is 0. Ultimately I just wanted to find out, right, number of dice rolls or number of distances, number of moves. So I can just say a distance array is equal to a moves array, because ultimately in future problems you will see the shortest distance between node this and node that, the shortest distance from here to here. So BFS is always related to shortest distance from here to here, from here to here. So it is the reason that we just have normalized just saying, rather than moves, I will just write the array as distance, which will actually show me, okay, the distance up till here from here is 0, which means number of moves, because we are starting from 1 itself, right? So number of moves are 0. Then I just, in move 1, which means in distance 1, I just reached at this particular portion. So to reach at 15, 1, 4, 5, 6 and 7, my number of moves required are nothing but 1. Again, if I just go on to do every of these nodes, and also from every of these nodes, like every of its child, I just go on. So again, the distance will be nothing but 1 plus 1, because it's the next. It is 2. Distance will be 2, which means number of moves will be 2. Ultimately, again, I'll just go on to every of this child. It will be 3. Again, I'll just go. Ultimately, it will be 4. So I'll just keep on going ultimately until I find my actually node, which is n square. It is the same thing which I've written. I will just traverse level wise and will just try to find the node n square until I reach that node n square. And as we're traversing level wise, because we want to find the shortest minimum number of moves, shortest distance or minimum number of moves, both are same thing, required, thus we are using a BFS traversal. Now, we for sure know, okay, we are grabbing, we are just moving down the level, we wanted the number of moves, and number of moves we are just grabbing as a distance array, because it's very standard to use a distance array in a BFS traversal. So how it is being updated, it's nothing but, as we saw earlier also, if my distance of parent is so far, let's say something as 4, so distance of child will be nothing but my distance of parent plus 1, because it's just next parent and then child. It's nothing but plus 1. If now know, okay, how my BFS traversal will look like, I'll just start my BFS from node 1. I'll just do a traversal in which I update the child distance plus 1, and as soon as my sums, as we know that a few cells are actually modified, so I'll just, if they're modified, I'll just modify them to actually reach to their actual cells. Basically, if I reach to 2, so rather than putting 2, I'll put a 15. I'll show how, and ultimately I just keep on try to reach the node 36. As soon as I reach it, I'm good. I have found my shortest distance, which means minimum number of moves required. Let's see the code pretty quickly. It's pretty easy. It's nothing but what we did. It's just that how we try to code that same thing. Anyone can code it differently. I'll just highly recommend for you guys to code it actually with yourself. The same code I'm going to show you in C++, but exactly same code is also being pasted in Java also, so you can just grab grab that PDF out, open that PDF parallelly with this code. It's exactly line by line the same thing. Cool. Let's see. Firstly, we have some variables we initialized. We can just have it anything. Now comes the main part, which is the cells array. This is nothing but it will just grab me. See, what I wanted was for every cell right here, it is a cell 1, right? It is a cell 1. I should know, okay, the cell 1, but the actual cell in a matrix is represented by its row and column. So I just say, okay, this cell 1 actually is the cell at the row 5 column 0. So I just need to maintain that. Thing. Why? Because when we are iterating on this particular whole thing, okay, if I'm moving, because I just know I have to start from 1 and I can reach to 2, 3, 4, 5 and 6 and 7. But the input which is given to me is this boards array. Boards array is nothing but a matrix, which means if I am saying, okay, I move from 1 to 2, I should also be knowing from 2 I can reach to 15, and this thing from 2 to 15, it's actually told by my board matrix, which actually gets the input as row and column. So to actually tell for 2, my row and column is this, which is 5 and 1. Now I will just give it the input to my boards array and will just let it know. Okay, boards array of 5 comma 1, it will give me 15. So I'll just say, okay, my 2 actually points to 15, which means I'll just replace my 2 by 15. It's the reason I just needed my number, which means 1, 2, 3, 2 actually points to 15, which my 2